Hello everyone. I want to work this problem from section 8.8 as it's similar to one on the homework and it's also similar to one on the final. It also ties together a lot of chapter 8 ideas, so it's good for review too. Before I work it though, I want to drag in a picture of what's known as a Dobro, an acoustic guitar with a metal plate that has unique resonant qualities. Our word problem actually talks about Dobros, and at first I thought this was a fictitious word like widgets for some pretend manufacturing item, but no, Dobros actually exists. And the nice thing about our word of the day is that it goes a long way to explaining the company's name here, which is Sweet Harmony Crafts. They've determined that when you build and make 800 x100 Dobros, that when x 100 Dobros are built, the average cost per Dobro can be estimated by this function here, where C of x is in hundreds of dollars. Now if you remember, I've stressed throughout the course that you can always replace the left side of a function with y. And that's my way of wrapping my brain around this in terms of x's and y's, ordered pairs, and the xy axis. So really what we're thinking here in terms of is something very familiar, an ordered pair in which the x value is in hundreds of Dobros. In other words, if our x input value is 3, we're talking about 300 Dobros. 4, we're talking about 400 Dobros. And our y, or output value here, is the average cost per Dobro. That will be our output. And notice that this is in terms of hundreds of dollars. So this is going to be in terms of hundreds of dollars. Now I'm going to just run a few hypotheticals on you to cement this idea down a little firmer. Suppose I was to input 2 into our function, and suppose, and I'm just making this up, we got out 3.5. That would mean that when we set up our factory and our workers to produce 200 Dobros, the average cost per Dobro is going to be $350 per Dobro. Now, we could run another hypothetical with our equation. We could input, let's say, 2.5, and we would get some output, and again I'm just making this number up off the top of my head. Suppose it was 3.3. Well, that would mean that when we make 250 Dobros, the cost of them decreases to $330 each. And the name of the game, as you'll see here, is to minimize the cost per Dobro. Let's get on to that and read it. It says, what is the minimum average cost per Dobro, and how many Dobros should be built to achieve that minimum? So what we're talking about is a quadratic here, and this deep into chapter 8, I know that you know that all quadratics graph as a parabola. And also, I think you realize that when the coefficient of the x term is positive, the parabola is concaved up. And alternatively, when the coefficient in front of the x squared term is negative, the parabola is concaved down. Now, what we're after here is a minimum, and in terms of the parabola that we're given here, the coefficient is positive, and so it is concaved up, and we call the vertex, or the turning point, a minimum when we reference it against the xy axis. In other words, imagine that this parabola graphs in the xy plane in the first quadrant, and you remember the ordering of the quadrants. Now I'm not sure where it graphs, but let's just pretend it graphs in the first quadrant, as it really doesn't matter for the point I'm going to illustrate. Namely, that when you take a point on the parabola and you chase over to its y value, as you go towards the vertex, the y values decrease, and the smallest y value you're going to get will occur at the vertex. That's why we say it is a minimum. So the question then becomes, since we are after a minimum, is how do we find the vertex since it represents the minimum? And there are two ways to do that. One is to complete the square, and the second way is a formula that generates the xy coordinates for you. I think that the formula is the more computationally safe path to take. And the formula looks like this. Now, what we're going to do is find our b and our a and crunch the x value out. And then we are going to march that x value in to the function as input. In other words, it's going to go there, there, and there. And we are going to crunch out the y value, or the output. So the question now becomes, what is the b and the a? And we use the quadratic equation in standard form like this as a way of referencing that. The a is the coefficient of the x squared term, and the b is the coefficient in front of the x term. So our a here is going to be 0.1, and our b here is going to be a negative 0.7. Please notice that I said a negative 0.7. You certainly could think of this subtraction here as the addition of a negative 0.7. My way of thinking about it is just to take the whole term like that. That gives me my negative 0.7. So however you do it, we need to fill in this formula. And so I'm going to flesh this out a bit. I'm going to put parentheses around my two input values. And that is to avoid a common error I see in terms of double negatives. Notice my b, negative 0.7, goes in parentheses, and that in front of those parentheses is another minus sign. The bottom of the fraction is 2 times a, or 2 times 0.1. On top we have the double negative, or simply 0.7. On the bottom we have 0.2. This is really 7/2, or 3.5. So that is the x value of the vertex, or the minimum. It is 350 Dobros. So when we set up our factory and our workers to produce 350 Dobros, we will find the minimum cost per Dobro at that value. So the question is, what is the minimum average cost per Dobro? And to find that, we need to input 3.5 into the function. So this now becomes nothing more than a substitution problem, looking like this, and the addition of 2.425. Now you can go ahead and crunch this out. It's an order of operations problem. We've done this throughout the semester. I've already done it. C of 3.5 is equal to 1.2, or in terms of hundreds of dollars, we are talking about a cost of $120 per Dobro. So the absolute sweet spot for this company, for Sweet Harmony, the number of Dobros that they should set their workers and equipment to making is 350. If they do that, they reduce the cost per Dobro to 120. Any other value, like 349 or 351, will be on the other side of the parabola, the legs of the parabola, going up from the minimum. Okay, I hope that helps with the one on the homework and the one on the final. Good luck with the rest of Chapter 8.